Welcome back to the cutting edge stage at CogX 2021. I'm your MC, Jess Wade, a research fellow at Imperial College London. Please remember to share your thoughts and ideas throughout the festival on social media using our hashtag CogX2021. Now we're in for a real treat with 10 times our future processing power in an AI world. In this session, we'll hear from Will Summerlin, a leading analyst at ARK Investment, as he delves into how neural networks will help society overcome limits in computing capacity. He'll be exploring this fascinating topic with Jennifer Schenker, founder and editor-in-chief at The Innovator. Over to you, Jennifer.
It's my pleasure to introduce Will, who, as just mentioned, is a San Francisco-based AI and software as a service analyst at ARK Invest. And for those of you who aren't familiar with it, it's an investment management firm that has over $50 billion in assets under management. Before joining ARK, Will worked in product management at Lyft. And prior to Lyft, he was the founder and CEO of Pin AI, which raised $10 million in VC and developed an award-winning AI-powered security platform. He has consulted growth stage startups and large enterprises on strategy, M&A, and product management. And as just mentioned, the focus of our conversation today is on how neural networks can help overcome limits to computing capacity and how that could help corporates gain a competitive edge. I'm going to encourage everyone who is participating in this session to please send your questions through on the platform, so that I can make sure to include those when we get closer to the end of the session. So let's kick off with a question about Moore's law. As just about everybody knows, in 1965, Gordon Moore, one of the founders of Intel, observed that computing power was doubling every 24 months and could continue to do so. Now, the chip industry managed to live up to that prediction for decades, but we've now reached the end of Moore's law at a moment in time when we're trying to solve increasingly complex problems. Should we be worried, Will?
It's a great question. So, just to zoom out here a little bit, if you think back to the origins of artificial intelligence, the vision for AI was essentially laid out at a conference in the late 1950s. And the idea and the vision at the point at that time was to create a system, machine intelligence system, that was superior to human intelligence. And back in the 50s, computing power was just infinitesimally small compared to what it is today. So it was a very bold vision back in the 50s. And if we sort of accelerate through to the late 90s, IBM had the first big breakthrough when they beat the world champion at chess using a system that was partially built on AI and machine learning capabilities. And from there, obviously we've continued to advance at an accelerating rate. And one of the reasons why AI is so important is because it allows us to solve these computationally difficult problems with the compute capacity that's available today. We did some interesting research internally at ARK Invest and kind of modeled out how long it would take, to do something like beat a world champion at chess if we didn't have AI, and instead we were using other statistical models to try to approach the game and process and simulate all possible moves and plays. And it's something that wouldn't be possible probably in our lifetimes. And as you start to get into more complex tasks and problem sets, think about self-driving, for example, it's really essentially impossible in many ways to try to accomplish those tasks without AI and without neural networks. And so, more recent advancements that we've seen, from places like Google and Facebook AI and OpenAI are really proving that AI has the ability to sort of shortcut just raw compute limitations. So one example out of Google is AlphaFold. which solved a very difficult computational biology problem and really, broke all the records in the field. And computational biology is one of those fields that historically has been very much limited by compute capacity. So, broadly, I think that general neural network evolution is allowing us to solve these computationally difficult problems that otherwise wouldn't be solvable in the near term, and in many cases, even in the long term. I think the other aspect of this that's really fascinating as well is how the computational efficiency of neural networks is improving. And so, as more research goes into neural networks, we find more efficient ways to actually run neural networks, train neural networks, use neural networks. And so there was an interesting study I saw recently out of OpenAI that suggested over the last 7 years, the computational efficiency of neural networks has accelerated or improved at a rate of about 68% year over year. And so what this means is, last year, or this year, a neural network to accomplish a specific task can do it with 68% compute than it needed last year. And this is really a compounding effect. And so if you play this out over a decade, what right now might take a room full of supercomputers could possibly be accomplished on your smartphone in just 10 years, if we continue this trajectory of computational efficiency improvements. So to answer your general question, I don't think that the slowdown in sort of computational evolution is gonna present too many problems in the future.
Well, so the example that you used with AlphaFold, I mean, we know that scientists had been trying to do this for decades. And so it was, an incredible breakthrough. But it seems like up until now, it's mainly the big technology companies, the Googles, the Facebooks, OpenAI, that are really benefiting this. Why aren't more traditional companies reaping the benefits of neural networks?
That's a great question. I think there are a few factors here. I think one is talent. There really aren't that many people who are great at AI. If we're talking about AI researchers, engineers, data scientists, who have been through the programs at Carnegie Mellon, at MIT, at some of the other great research institutions. There just literally aren't that many people, and it's a relatively new field. As far as engineering is concerned. And so you might have 2,000-3,000 people who are really good at AI, who have worked on these really interesting programs, and Google and OpenAI and Facebook and the other big tech companies are going to siphon those people away as quickly as they can. And they have a really compelling pitch to these engineers and these data scientists. They'll give them great compensation, and in many cases, a senior scientist at a Google or Facebook can make $1 million or more a year. They get to work on really cutting edge problems. They get to work with other people who are smart and ambitious like them. And you get all the perks of working at a Google or Facebook, right? You get all the free food and everything else. Maybe not right now with work from home, but all the perks that come along with it. Whereas,
if you're a ball bearing company, you might have trouble attracting those folks, right?
Yeah, exactly. If you're a legacy company, an old world company, the challenge is, attracting and retaining those people. And, it's culturally, it would be difficult, I think, for a legacy company. It's not a technology company, to hire somebody straight out of a PhD program and pay them $1 million a year. I think most people would look at that and say, that's crazy. Why would we ever do that? Whereas the big tech companies really understand the value that AI can provide and are willing to make those investments. So I think talent is certainly one aspect of this. I think the other aspect of this is, AI is currently expensive to build, right? It's talent is only part of the cost. The other half of the cost is raw computational power. And so if you look at something like a GPT-3, which is the largest language model out of OpenAI, that was a very expensive model to build. The final training likely costs over $5 million. And if you sort of add up all the other training iterations to get to the final model, it very well could have cost, $100 million or more just to train that model. And so that's a huge allocation of capital. And if you're not an organization with a big balance sheet, or an organization that's purpose built to try to break through these barriers in AI, it's going to be hard to convince your CFO that you should spend $100 million on this project with an unclear outcome. And so I think that's also a factor at play.
So what do you advise companies to do if they can't get the talent and they can't afford to develop this? What are the options? Do they wait for quantum computing?
Yeah, so I'll start with quantum computing and then throw out a few ideas. Yeah, quantum computing is an interesting field. It seems like for 30 years we've been 5 years away from the breakthrough that everybody's been waiting for, and it hasn't come yet. There's some interesting, promising research coming out of some new companies who are trying different approaches to manage error correction that could, potentially lead to a breakthrough in a 5, 7, 10-year time horizon. I'm a little bit bearish on quantum computing in the near term, just based on what I've seen so far. I think we're still a ways away from commercial viability. And so if you're a ball bearing company, I wouldn't bet on quantum computing solving your problems. But I think there are a few things that you could do as an organization to try to embrace AI. Just because you don't build the core models doesn't mean you can't benefit from AI. The OpenAIs of the world, the Googles of the world, they're starting to release their core AI models as commercial products. And so GPT-3 actually has over 300 applications built on top of it. From startups and sort of mid-sized companies ranging all the way up to big corporations building chatbots and grammar correction models and all sorts of other things on GPT-3. And so if you're a company that doesn't have the ability to actually build these complex core models, you can still build software on top of those models and still create value. But we think much of the value will accrue to those who actually own the underlying models. And so in the short term, it's a way to create value, but it's going to be a lot of the value creation will likely go to those who own those underlying models. I think another thing that you could do potentially is partner with startups. The great news about startups is they're full of really smart people in many cases who are trying to solve problems, who are really in many ways desperate for a customer. And so if you see a AI startup that was spun out of a team at Google or OpenAI, and there are dozens of these, a team of scientists and engineers break away from Google and go through Y Combinator and start a company trying to apply AI to a specific niche or problem set. If you're a ball bearing company, try to find those startups and partner with them. They're in many cases, and I've obviously built a startup before, so I've been here, boots on the ground, and seen this. They're willing to, in many cases, willing to bend over backwards to try to solve your problem, right? To get a reference customer, to prove value. And so another way to approach this could be to find those hungry, ambitious startups with a great set of talent and partner with them and try to solve problems together.
Okay, thanks. And so let's shift slightly and, can we talk about whether businesses should be thinking about AI at the edge, and how does that fit into the overall picture?
Yeah. So, traditionally AI has sort of been built with this cloud computing hub and spoke model where, you have a model that sits on a server in the cloud and you send your data up to the model and the model performs whatever it wants to do and then spits out a result and sends that back to the edge. And that makes sense sort of logically for research and for many AI applications. But there are applications where you want that processing power closer to the edge. And the two main drivers behind that are cost and speed. And so I'll start with speed and then talk about costs. So there are AI applications like self-driving, where you can't wait for a response from a server, right? That half-second latency could be the difference between life or death. And so you need as little latency as possible in the system. And in those applications, it makes sense to have computing power as close to the edge as possible. So if you look at self-driving cars or autonomous vehicles, in almost every case, they have a computer literally on the vehicle that's running the AI algorithms. The other reason you would want AI at the edge is cost. And so for certain applications, and I believe this was from NVIDIA, gave this example. If not, it was another chip manufacturer. If you wanted to enable voice commands on a coffee maker, you would spend about $15 a year in compute. And so if you wanted to enable your customers to wake up every morning, walk into their kitchen and say, hey, please make me a coffee, and have their coffee maker actually perform that task, and you were sending that data to a AWS or a Google Cloud and running an algorithm on the back end, it would cost about $15 a year in compute costs. Coffee maker only costs $30. And so you would spend, half the price of the coffee maker every year just in cloud compute. And customers probably won't pay for that. And if you're a manufacturer of coffee makers, you certainly don't want to pay for that. And so in those cases, it makes sense to buy a $2 or $3 chip that has the ability to do very basic sort of voice command processing and put that actually at the edge. And so, you can embed a cheap sort of simple chip on the coffee maker that has the ability to process voice commands, and save $12, $13 a year in compute costs. And so I think there are applications where just sort of the cost is a main driver, and it's sort of unbearable, to put those models in the cloud. You kind of have to push them to the edge for it to be economically viable.
And there are, I think, a number of business cases, using Internet of Things that, like, say, in factories where latency is also an issue. But to what extent is all of this dependent on the introduction of 5G?
It's a great question. I think in some cases it is dependent. In other cases, it's not dependent. I think 5G, and the promise of 5G is that it will sort of accelerate the pace of IoT adoption. And so to the extent that it has that effect, I think it's great for AI at the edge. The more IoT we see in the world, the more opportunities there are for AI to be pushed to the edge and solve some of these problems where it's currently not viable, either due to sort of latency or due to the cost factors.
Okay, thanks. So let's talk about data network effects and why many AI opportunities will likely be winner takes most, and what are the implications of that for non-tech companies?
Yeah. So, if we zoom out and think about sort of the technology revolutions throughout history, there have been, certain competitive advantages that have defined the most successful companies. And if we go back to the Industrial Revolution and, all the way through the 1900s, it was really economies of scale, right? If you look at the Rockefeller case study, for example, they won because of their economies of scale. They were able to produce oil and sell it profitably cheaper than it cost their competitors to just produce oil. And so, those economies of scale were really beneficial. And if you zoom into like the late 90s and really the early 2000s up until today, many of the most successful companies have benefited from network effects, where every addition to their network, right, Facebook, Instagram, being example, adds an order of magnitude of value to the network. And so the more people that are part of the network, you see sort of value of the network grow exponentially. And if we think about AI, there's this idea of a data network effect or data advantages that I think come into play. And my opinion is that data advantages will likely be the competitive advantage that defines or underpins the most successful companies of the next 15 to 20 years. And just to kind of define this, typically the quality of an AI model is very much dependent on the quantity and quality of training data. And so what we've seen historically is the more data you add to a training set, the better your AI model becomes. And we've seen this with GPT-2, GPT-3. They keep throwing more and more data at it and assume that we're going to hit an asymptote at some point. But the more data you add, the better the model becomes. And in some cases, this data is easy to acquire. right? In the case of GPT-3, they basically just took most of the text off of the internet and built a model based on that. And so, there's not a huge competitive barrier there. Most research organizations could probably copy it and do something similar in terms of acquiring training data. But in other cases, the data is very hard to acquire. And so, to give an example, self-driving vehicles. It's the analogy I always give is this idea of a blue stop sign. So believe it or not, Hawaii actually has blue stop signs in certain places. And a typical self-driving car would come up on the blue stop sign and probably be confused, right? It would see it, it would say, wait a minute, stop signs are red. I don't know what that is. And it would either, flag an error, or it would, think it's something else and just blow through the stop sign. It needs to actually see that blue stop sign in real life to recognize that, oh, wait a minute, this actually is a stop sign. And so if you're a self-driving car company and you have your vehicles operating, all over the country, if you don't have, and if you haven't seen an edge case instance before where a car comes across a blue stop sign, you're not going to have that training data. And so, if you think about sort of the self-driving vehicle example, the more vehicles you have on the road, the more training data you're collecting, the more edge cases you're going to see, the more performant your core AI models will be. And the more performant your core AI models will be, the better your product and the more customers you'll get, which leads to more training data. So it's a sort of cycle where, in many cases, more data equals a better product, equals more customers, equals more data. And if you start to spin this flywheel, you see a gap starting to form between, the clear market leaders and everybody else who's following behind. And so I think, in many cases where AI is embedded in a product and it's a core feature in a product, there will be sort of winner takes most outcomes where companies that are already sort of in an advantage position from a data perspective will continue to maintain and in many cases grow the gap between them and competitors.
So today, a lot of traditional companies, particularly here in Europe, actually do have a lot of data about their sector that might not necessarily be available to Google, but they don't have, as you mentioned earlier, the talent. And they probably haven't cleaned their data properly or organized it properly. Where do they go from here if they can't get the talent? They can't develop it themselves, but they do have the data. Is all lost, or what would you advise them to do?
Yeah, that's a great question. So there are really, if you want to think about this in sort of three parts, to create a really effective AI system, you need the data, you need the infrastructure to actually clean and label that data, and then you need the ability to train neural networks using that clean labeled data set. And in some cases, you don't need labeled data. We're seeing more self-supervised learning come out that's less dependent on labeled data, which is fantastic. But as of right now, the sort of standard is you need high quality labeled data set in order to build sort of best in class AI models that are task specific. And so, if you have that data, that's great. And I think you're in an advantage position if you understand that you have that data and you see that asset. But I think what you need to do is figure out the other two parts, right? You need to figure out how to clean that data, get it labeled, get it prepared for something that can be used in AI training, and then actually start to build these neural networks and train these neural networks. And so going back to a previous example, I think this is a great opportunity for those companies that recognize the value of their data to partner with third parties, to partner with startups, to help them through the next two phases, right? To help them clean that data, to help them label that data, and then to help them actually build useful applied AI applications. And so, if companies recognize the value of that data, that's fantastic. And if they can move through the next two phases, which often are the more difficult phases, I think they'll be able to unlock some value from that data and hopefully create value.
Okay, thanks. So we have a question from the audience. They want to know, does ESG now sit alongside AI? Put another way, will tomorrow's semiconductor winner be the company with proven, environmentally friendly, made energy efficient chips with computational power?
Yeah, I think in the context of ESG, there are two ways that AI fits into this. I think the first is what we talked about with computational power, right? When you have a server farm, it's consuming a lot of electricity. And to the extent that neural networks can make sort of computational problems more efficient, we'll need less energy to perform those problems. And so I think on one hand, the promise of AI is that it'll actually allow us to do things we're doing today and do things we want to do tomorrow with less sort of energy than would be required without AI. I think the second aspect to this is AI can help us sort of break through and optimize some of the current systems that consume a lot of energy or are otherwise running afoul of sort of ESG standards. And so to give you a really simple example, imagine that you have an HVAC system in a commercial building. There are AI applications that can help you sort of optimize usage of that HVAC system such that you're consuming the minimal amount of energy possible. Another example, there are AI systems being built that can help lead breakthroughs in sort of in wind power, right, or in other forms of alternate electricity or alternate power generation. Helping design those systems, helping figure out where to place those systems, et cetera. And so I think the second sort of promise of AI in the context of ESG is that it's an accelerant that helps us both optimize our current systems as well as design and implement new systems that are more efficient than those that we're currently using.
And it also sort of puts a more positive spin on the use of AI. I mean, a difference from the sort of Darth Vader, robots who are going to take over the world kind of thing. And so I think we need to think about how AI can positively impact the world and actually help us solve the UN's Sustainable Development Goals from an energy standpoint, but also on things like drug discovery. To go back to earlier on in our conversation, we were talking about applying protein folding, but I know that the increase in computational power is also going to be very important to the pharmaceutical industry and drug discovery. Can you comment a little bit on that?
Yeah, for sure. So in the context of drug discovery, I think there are two core value propositions to AI. The first is that it will let us solve problems and create cures to diseases that we otherwise have not been able to solve. But the second, and I think this is more interesting to the ESG point, is it will likely lead to cost declines. So if you think about the cost, why are drugs so expensive? Everybody talks about sort of drug prices and why drugs are so expensive, or the fact that drugs are so expensive. The reason drugs are so expensive is because it's this very, very long process of elimination to try to find a drug that works, right? You start with 100 million possible combinations of drugs, and you have to whittle it down to the 2 or 3 that are possible candidates. And that's a very long and expensive process. And a pharma company has to invest billions of dollars in many cases to get through that pipeline. And at the end, they might not even get a drug that works. And so it's very expensive, very complex process that's being run currently. And unfortunately, that cost gets passed along to the consumer. A company that spent billions of dollars developing a drug wants to obviously recoup their investment and then make some profit on top of it. And so, you and I end up paying exorbitant prices for drugs. Whereas, with AI, the idea is that we could actually shorten that drug development pipeline and run it much more efficiently. And so if we're able to sort of lead to cost declines where, the cost to develop a new drug isn't $1 billion, but it's $10 million, just to throw out some hypothetical numbers, then the cost to a consumer will be much lower. And so I think that the promise here is that AI could actually be a driver of cost decline, which would result in lower cost cures and treatments to the general population.
Beyond drug discovery and energy, how else would you see, the impact of neural networks on computational power impacting either the SDGs or, like, say, making major improvements to society. Which industries where do you see this hitting kind of first?
Yeah, that's a great question. The promise of AI in many people's minds is that it will free us to do things that we want to do, and sort of automate the tasks that humans don't want to do, which will ultimately lead to net positive sort of productivity gains for society. And I think one of the things that's sort of misunderstood about AI is that, or one of the fears about AI that I think is shared broadly. A lot of people think that AI will automate everybody's jobs and we'll all be out of jobs. And I just don't think that that's true. I think if you look at any sort of technological revolution throughout history, it's led to net increases in productivity for society, right? If we think about the shift from from hunter gatherers to an agrarian society, we didn't spend all of we sort of were free from hunting for our food and picking berries all day. And we use that free time to be more productive and build new things and create new value for the world. And if you think about the Industrial Revolution, it was very similar, right? And I think AI promises sort of a similar outcome where we're able to automate away a lot of the tasks that humans currently do that are sort of not the most productive ways to spend our time or not the most exciting ways to spend our time. And it will enable people to sort of work on other things that they find interesting, right? I find that everybody has a passion, and the unfortunate reality is most people aren't following their passions in their professional life. Somebody might be a great musician, but they drive for Uber or Lyft to make a living. And how great would it be if that person could actually follow their passion and make a living doing that, right? What if they could play music and make money doing that? I think technology broadly has been an enabler, and allowing people to follow their passions. If you think about the gig economy, if you think about some of the streaming services, the Twitches of the world, et cetera, I think they've really sort of created this world where people can follow their passions and they can do very well economically following those passions. And I think that, as we start to see, automation increasingly eat away at some of these different functions in society, the hope is that people will be able to reallocate their time, reallocate the labor to sort of net new things that will create even more productivity and more value for society. And so that's sort of how I see the future and how I envision the future in a world with AI. The transition is not going to be perfectly smooth, right? It never is. We're going to have a period of time, 10, 15, 20 years, where people are displaced and there's going to be, transition period. But I think technology will help people find new tasks and new ways to be productive. I also think, on the sort of same thread, one of the other promises of AI and neural networks is that they will, enable people to, to up-level their skills and create value in ways that they weren't able to before. And so, to give you a very simple example, historically, if you wanted to build an app, for iPhones and Androids, you had to know how to code, right? You had to get a download Xcode, you had to learn Objective-C or Swift or Java for Android, and that's relatively complicated, and it was a huge barrier for many people. So you could have a great idea for an app, but if you don't have either the money to pay somebody to build the app, or this sort of unique skill set to be able to actually code an app, then you probably weren't going to be able to create an app. And with new tools, in many cases being enabled by AI and neural networks, we're seeing sort of low code, no code applications where somebody with very little software experience, and not a lot of money to spend on building an app, can actually build a low code, no code app, right? They can use one of the commercial tools that are underpinned by AI and underpinned by machine learning to build their own applications and create value for the world. And so I think it's sort of breaking down the barriers that have historically existed around unique skills needed to create value in the digital world, which is very exciting.
Yeah. So, I mean, to kind of sum up, I mean, we are talking about how the computational power of that neural networks underpin can, help us make scientific breakthroughs, to drug development, help us become more energy efficient, and bring to life many of the applications that not so long ago seemed very far away, like self-driving cars, etc. And I think that you brought out some great points about how neural networks can also help us solve the sustainable development goals, but also to unleash individuals' creativity and hopefully make people happier about what they do with their lives and their passions. So we're getting close to the end. What is the key message that you'd like to leave with the audience, Will?
I would say that, I think that AI is going to evolve more quickly than most people realize. If we look at technological innovation, I think, in most cases, people sort of underestimate or overestimate what we're going to do in the short term and underestimate what we're going to accomplish in the long term. And I think that's certainly true with AI. If you go back to the 1950s, when AI was sort of, created, I think many people at that conference probably expected it to be 30 years before we had a computer that was smarter than a human. And, obviously, if you go into the 1980s, we didn't quite have that. And so I think initially the development took a little bit longer than most people expected, but I think AI is really starting to hit its stride. And if you look at just the sheer amount of financial and human capital that's being deployed and allocated to work on AI, I think we're going to be very positively surprised by what the world creates, in the next 5, 10, 15 years. And just the pace of research is quite astonishing. It seems like every week there are 5 to 10 great research papers coming out of Facebook, Google, OpenAI, research universities that are really demonstrating these major breakthroughs in AI. And if you sort of look back 10 years ago, there was maybe one of those papers a month. And so I think just the pace of research alone is just accelerating at an incredible rate. And it's building on top of each other. And so, research that's coming out of Google will likely help OpenAI on their next project and vice versa. And so we're just seeing these building blocks being formed. And the rate of innovation is really quite exciting. I also think that, AI is going to be applied in many ways that we don't realize today, right? And there are so many problems to solve in the world. And I think AI is one of the tools that will help us solve many of those problems.
Thanks, Will. And so I think we have about 3 minutes left, and we have another question from the audience, which is, and your last point, which was a great segue about how it's going to help us to solve problems in unexpected ways. Someone in the audience asked, how is AI helping reduce our wasted energy, approximately 50% of the world's energy? Do you have a view on that?
Yeah, I do. So, it goes back to, what I mentioned just a few minutes ago, which is, I think that in the context of energy consumption, I think AI can both optimize our usage within our current systems, but also help us create new systems that are more efficient from the ground up. And so, within our new systems, right, if you have the example I gave, if you can optimize sort of HVAC usage within large commercial spaces, you'll probably reduce the energy consumption of those HVAC units, which is great. And I think we should do that. And AI should be applied broadly to current systems. But I also think it can help us push the boundaries with new systems, right? And so if you take wind turbines as an example, and you use AI to help develop an optimal wind turbine and then place that wind turbine and then operate that wind turbine, you'll probably get, improvements in efficiency over another company who's just using humans to design and deploy those wind turbines and using legacy software to operate them. So I think AI can help us also create these new energy systems that are more efficient from the ground up.
Great. Well, we're just about out of time. And so I want to thank you, Will, for fabulous intervention. And I want to thank everyone in the audience for participating and staying with us. Thank you all very much.
Thank you.
Over to you, Jess.
Thank you so much to Jennifer and Will for all of your time and all of your thoughts and ideas. If there's one thing that I'm taking away from this discussion, it's not to jump into a self-driving car in Hawaii just yet, but maybe in the future. And I'm really grateful to you both because we're all really about positive spins and beneficial uses of AI at Cognition X. To everyone in the audience, please don't leave the cutting edge stage. Coming up next, we're talking democratic algorithms with Beth Singler and the superstar Max Tegmark. Thank you so much for joining and see you all again soon.